Qualitative tests are used to identify ions in compounds. Solid X contains two ions. The test for these ions and their results are shown in figure 10. So a flame test on solid X produces a red-orange flame, so that will be the metal part of the ionic compound. And dilute nitric acid is added to an aqueous solution of X, followed by a silver nitrate solution, and a white precipitate forms. Precipitate reactions show the non-metal part of the ionic compound. Use the information in figure 10 to name the cation and the anion in solid X. A cation would be the metal ion, and this would be, the anion would be the non-metal ion. So firstly, you just need to memorize certain things. A red-orange flame is likely to be calcium. Just remember the various flame tests. So copper, for example, would be blue-green, sodium would be yellow, potassium would be lilac, but calcium is a reddish colour, brick red. So the name of the cation, the metal ion, would be calcium. And finally, a white precipitate forms when you add nitric acid followed by silver nitrate. So silver nitrate, it's just a matter of memorising this really, three things here. Silver nitrate is used to detect chloride ions. When it does react with chloride ions, and you prepare it by adding nitric acid, HNO3 is nitric acid. So silver nitrate, when it reacts with chloride ions, the silver bonds with the chloride ions to form silver chloride, and that is the white precipitate. And so this is just a matter of memory. You'll get calcium chloride. Another, I would actually just memorize that table, it's very useful. Another solid, Y, also contains two ions. A test was carried out on Y. A few drops of sodium hydroxide solution were added to a solution of solid Y. A white precipitate formed. Give the reason why this test does not identify the cation in solid Y. So what this is happening here, you have to kind of use intelligent guesswork here, is that the metal ions, or the ions in this solid, are reacting with the hydroxide to form a metal hydroxide, which is forming a white precipitate. But the reason why you can't identify it, and you could probably logically figure this out, is more than one ion or cation will react with a hydroxide ion to form a white precipitate. So if you have two ions, let's say for example calcium or lithium ions, imagine if they were both in there and they reacted with the hydroxide, they'd both form white precipitates, so you can't identify which one you've got. So more than one cation can form a white precipitate. Give a reason, or the reason why this test does not identify the anion in solid Y, in other words a non-metal ion. Quite simply because we're using the wrong chemical. Sodium hydroxide is not used to test for anions. It's the kind of question I think any student would get wrong because they might not be tuned into it. But remember, these are the ones we use to detect for negative anions, negatively charged anions. Instrumental methods are often used for analysis. Give a reason why instrumental analysis may be better than other methods of analysis. So instrumental meaning using data loggers or something like that, scientific equipment that can give you accurate readings rather than just looking at a colour change. They're basically more accurate and faster, so using like a data logger and a temperature probe or some sort of probe will give you a real figure, and it'll do so quickly. You don't have to wait for a chemical reaction to occur, for example. Right, iron 2 sulfate solution reacts with sodium hydroxide solution to form a pale green precipitate of iron 2 hydroxide, FeOH2. Write the ionic equation for this reaction. These are always the trickiest types of questions, I think, in chemistry, if you're not tuned into them. So start by going, what ions are reacting to make FeOH2? Well, obviously, iron ion and 2 hydroxide ions. So that's got to be involved in it. So we only need to concern ourselves with the things which involve the ions, so we can ignore all the ions we need. So there's a bit of noise in this question. We can ignore the sulfate and we can ignore the sodium because the ions are what we're interested in, the iron ion and the hydroxide ion. So you just write Fe2 plus 2OH minus will give you FeOH2. You'll just have to remember that iron forms a 2+ ion. The green iron 2 hydroxide precipitate gradually turns brown when exposed to air. Explain this observation. So you have to give a reason for why it's occurring. So if you remember, this is an oxidation reaction, oil rig. So oxidation is loss of electrons, reduction is gain of electrons. So if it's an oxidation reaction, we're losing electrons. And you can see here we go from Fe2 plus to Fe3 plus. So the only way you would gain a positive charge is by losing another electron. So you'd say iron 2 ions oxidized by air, so they're becoming oxidized to form iron 3 ions. Or you could just write down the half equation, Fe2 plus to Fe3 plus plus an electron, because this has lost an electron.